second slide, I've asked one question like what happen if the block is added to the blockchain and then also someone tries to change that data. So there is a term which you need to understand, that hashing. So hashing is converting any data into a fixed length of cryptographic string. So hash is a, we can say, a cryptographic string which of unique numbers which can be derived from its input. Let's suppose that here is hello world is written and there is the hash of this hello world. You can see this random number. And if we have done a very minor change, we have just changed the W from capital to small, you can say this hash changes significantly. Now, how this hash is calculated, that is a different part. There is some mathematical computation behind this, that we compute this hash from some this string. So this is hello world string, and this is the hash of this string. And if we change just a capital W to small w, you can see how this hash changes significantly. So this is the hashing. Now, how this is linked with the previous question, that if the block is added to the blockchain, then also you can, if someone tries to change the block, they cannot change. So I will take you to one image here to understand this more clearly, that how the immutability, or we can say the data cannot be changed once it is stored on the
Yash,
blockchain.
there is one question. Someone has raised hand. I can unmute him so that he can put his question. Is it okay to take this question at this moment, or shall we like cover the topic and then you will take the question, or we can take the question?
You can take the question.
Okay. So I'm unmuting, but yes. Okay. So
Sir, I
yes.
wanna. Hello, sir. Can you hear
Yes.
me?
Yes. Yeah.
Sir, I wanna ask, like in hashing, if hello world is stored in a particular hash, like SHA 256, so we have its hello world hash. If we
Hmm.
are if someone मतलब हम कहीं और hello world use करते हैं तो उसका same ही
Hmm.
hash generate होगा अगर same
But
same
in
word है.
S, they see there are different type of encryption method. In SHA 256 algorithm, that hash is always the same. But there are some
मतलब
other layer like
हम इसमें
AES.
हम इसमें salt वगैरह ऐड नहीं करें तो हैश तो हमेशा
Yes,
सेम ही
yes.
रहेगा.
Like there are the other encryption method like AES 256 and other. There, you will not, as in SHA 256 algorithm, it is just dependent on the input. Like hello world is the input here. So in SHA 256 algorithm, it is dependent on that. So it always generates the same hash for that input. But let's suppose if you, as you are saying, that if you add some salt, like in AES 256 algorithm, you take the input and then you salt it with some 32 bytes of integer as well. So for every input, it generates a different hash. But in SHA 256 algorithm, which is used in the blockchain here, it is same for every input provided to it. And any simple change into that input change the hash significantly. So as you question that, yes, it will generate the same output for that. But to tackle this problem, there are some other encryption method which you already mentioned, that adding the salt to it, which we do in the AES 256 and other encryption algorithm. So I hope it is clear to you.
Yes, like AES is advanced, so I thought like you said SHA is used for
Hmm.
hashing, but SHA is an old hashing algorithm that.
SHA is being used
I
for
will explain.
Bitcoin encryption, right?
I will tell you
So
how this is ensured in here. Yes, Varun.
Okay.
Are you saying something, Varun?
no, I was saying that SHA is a Bitcoin encryption mechanism. So, as you told that other blockchain technologies are using the other encryption mechanisms. So, it depends on the use cases. Like I want to highlight that every technology and every aspect of the technology is having their pros and cons. So, whenever we try to define the solution, we need to see what is the requirement, and if requirement is around the like safe security is the most important, or scalability is the most important, or the other aspect speed is the most important, so then we need to decide like which will go the best for the solution, and then we take a call like what encryption method or which blockchain we should use for the defined solution. But every technology and everything has its own characteristics. Yes.
So, if you understand this diagram, you will understand, like, it is one of the most important question in the interviews as well, like how the immutability is stored in the blockchain. Like we all understood that transaction happens in the blockchain. transaction get stored in the block get added to the blockchain after getting verified by the miners. But what happens if someone tries to change the data after the block gets added to the blockchain? So how this is ensured? So you have understood hashing as well. Like, what is hashing? It is converting a string into some cryptographic hash using some algorithms. So this immutability is in blockchain is stored with this term known as hashing. What happens in the blockchain once the block with all the transaction gets added in the blockchain? Let's suppose this block n is added in the blockchain after all the transaction and validation. This block is added, and now this block is connected to the previous block, and this block is also connected to each other through that hash. And how this hash is calculated? Now that's the thing. As we have told that hello world is a string, some mathematical computation happens, and that hash is calculated. In the block, that hash is calculated by some things like the timestamp of the timestamp is the time at which the block is added. So timestamp nuns, for nuns you can what is nuns? Nuns is just a random number for now, you can understand this nuns, and this so this all the and the previous block hash. So all these components which you are seeing, header, previous hash, timestamp, nuns, these all the parameters, or we can say all the elements of the block, are used to calculate that hash. So you can see one of the main important part is here, this previous block hash. Please note that we will explain how just changing the one block will invalidate all the blocks in the blockchain. So let's suppose I change some data here. Transaction here changes, and once it changes, my hash of this block changes. And as this block is connected, you can see the previous block hash. As the hash of this block changes, and this block is connected to this block through this previous hash, so this hash also changes. So the connection from this block breaks. So, and there are only 3 blocks. You can imagine it like there are 4, 5, 6 more blocks here. So as this chain continues, this hash breaks, this connection breaks, and the hash of this block changes. And as the next block is also connected to this block through this previous hash, that connection also breaks. So you can imagine how changing a single transaction, or we can say if someone tries to change a single transaction, the whole block after that becomes invalid. I hope you understand how. Let me explain this one more time if this is getting a little complex. This is the block. It contains this sum of the elements. You can, for now, just focus on this hash, previous block hash. This is the hash. This hash is calculated with some algorithm. Now, all the blocks are connected. Blockchain is valid. I changed the data here. And once I change the data, the input changes of the hash. So the hash of this block changes. And as this block is connected to this block through this previous hash, and the hash of this block is already changed, so this block disconnect from this block. And similarly, the block from the next, this hash also changes. So as the next block is also connected from this block to that previous hash, that block also breaks. So in this way, changing a simple data in a one block only invalidates all the blockchain, as all the blocks are connected. So the simple answer of this question is, as the previous block, as the current block is connected from the previous block through the hash through the previous hash of that block, and if we change the data in that block, the whole blocks become invalid. So this is the simple answer of this question, how the immutability is ensured into the blockchain. So here you can see it is just a simple block. As I told that this blocks contains lots of transaction. Let me visualize this even more by going on to the block explorer of Bitcoin. So the simple image which you are seeing here, it is just a simple square block. How this is storing lots of transaction, how this is getting stored in the blockchain, you can understand it better. So the simple structure which you are seeing here, just a simple square, or we can say cube, this is the actual structure of a real block. This is the Bitcoin blockchain explorer, where you can, as I've already told that blockchain is transparent. So all the transactions which are happening, you can see here. So this is the real structure of a complete block. See, you can see the small dots. Some dots are small, some dots are little bigger, and some are even bigger. So these are the transaction. And why the sizes of these blocks are different? Because it depends upon the size of the transaction. Some transaction may be simple, so they are small. Some transaction can be bigger than that, so they are little bit bigger. Some can have a very complex execution, so they are very big, you can see. So these small, big, and bigger, these all transactions combine into the block, and depends upon the sum. Every block has its block capacity. So it depends upon, let's suppose you have a memory card, let's suppose it's of 2 GB. So you are filling it with the some of the files. Some are of 2 MB, some are of 10 MB, some are of 15 MB. So these blocks get filled. So once these blocks get filled with all the transaction of different sizes, and once it reaches this block capacity, it gets added here. So this is the correct, and you can see the all the blocks which are added in the blockchain. You can also go to the first block which is added. So these are all the blocks, all the transaction happening in the earth currently. So these are all the blocks which are, you can see, this is all the sets of record, all the blocks hold lots of transaction and get stored in the blockchain. And this all are connected to that chain, to that hashing algorithm which we have talked about. So this is the complete picture of the blockchain. This is the real structure of the block, how a blockchain is connected to each other through hashing. What happens if someone tries to change the data into the blockchain? This is the complete picture. So which you can understand. Don't just think that this is just a block. This is the complete structure of the block. You can see how it is stored, lots of transaction. So I hope it is clear to you till here, like what is the life cycle, what is the life cycle of the execution of the, how the transaction happens, how that gets stored on the block. Then that blocks get broadcasted to all the computers. Then there are the miners who see and verifies that transaction. And then after their verification, that block get added to the blockchain and the immutability is stored to hashing. So this is the complete picture of the blockchain. So let's jump to the next slide. Like most of the people are confused. Like if you are already into the blockchain, then this is a very basic topic for you. But for the people who are little bit new here, like they confuse in between Bitcoin, blockchain, and cryptocurrency. They think that they are all just same things like blockchain, Bitcoin, everything is like same. So blockchain, we have already understood blockchain is this technology, this decentralized ledger stored on the multiple computers. This is complete blockchain. Now, Bitcoin is the application of this blockchain technology. This was proposed by Satoshi Nakamoto. This is a digital currency based on this blockchain technology. This whole picture we have just talked about, that this